Welcome to another episode of a very basic space program. So this episode is going to be a bit different because we're going to have a bit before an episode you've already seen and a bit after an episode you've already seen. So yeah, we're going to Venus. So please join me. Right, so here we are, and you will see that we have a Venus window in 105 days. We have a Mars window in 386 as well, which I'm tempted by, but it will require us getting tech to a certain level for that. What I do need to do, and I need to just check this now, is I'm going to need to get upgrading because this gives us a level 3. I really want to get to here. I really need to get here so that I can actually send signals to Venus and to Mars efficiently, which is going to be 69 science that we need. We're short, and I was going to save that for capsules. So yeah, it looks like we're going to go for communications first. So we have already got, if I close that down, we've already got this up to level 4, which is, I believe, Tech 3 level. We'll just check back in here now because we've got to do this. I think level 4 is actually Tech level 3. Is that right? So level 4 tracking station, yeah, is DNS level 3. So it needs another step up, which will come with this one, I believe. There we go, which takes it to level 5 and whatnot. So what that means for us is the following. I need to get to that before we get to Venus, in short. We've got 100 days before we have to set off Venus. But I need to get enough science to have started developing stuff and building things like this. So this is going to cost us 175. That's not going to take too long to build, okay? That's not a big issue. It is about getting the science done first. Now, these are going to run out pretty soon, actually. So we need to basically be getting our next chunks of science in. We are not getting any more science. Mainly because a lot of our craft are actually dead in the water. The solar panels are just not working. We've got geostationary, we've got this test sat one that's doing something, but that's about it. So we need to get this. I would expect that these explorers would get us a nice chunk of science, but I can't spend the time to build one unless I only send one of our probes, and I'm concerned that if I only send one probe to Venus, it will go wrong. So I'm going to send 2. We're going to send Discovery 1, Discovery 2. They have a slightly different loadout, but we're going to launch them. We're going to launch one slightly before the window, one slightly after the window. They should have the Delta V to get there. They've actually got enough Delta V to go to Mars as well, I think. So we can just modify them as we get improved tech, because I think things like interplanetary avionics and improved avionics should improve. Let's have a look. These are the ones down here. They're going to go up by, let's have a look. Power efficiency is going to drop by 15 and mass is going to drop by 15, and then again we're going to have mass dropping by 15 and power dropping by 15. So there's a big drop off there in mass and power need, which is going to really help us. And hopefully as we get communications improved, we're going to have that as well. The big problem we have is that actually our solar panels out at Mars are not very effective at all, in fact. So I need to work on that. So I'm going to fast forward this to the point where these are ready to launch. We'll launch them. We'll get them going, and then I'll have to basically pause this episode while I go and do some other stuff on the series and then come back to it. What I would really like to hear from you though is that what you want to see, or would you rather see me launch these 2, do some other bits of mission, and then in a later episode come back to them? Which is what I've done in the British series. I've interlinked things. We're not on a time scale here. It's 1963. We're not really pushing on very fast. I don't expect us to actually keep up with standard timelines because of the way I'm recording, and the way I'm doing things. But it'd be nice to know what you thought. So yeah, comment down below, tell me what you think. So I'm going to fast forward time, and we're going to get to launching the Discovery craft. So I will see you on the launch pad for the first one. Right, so here we are on the launch pad with Discovery 1. The sun is setting. We've got the lights coming on, very nice, although it's shining up that side that we can't see. Right, so we're going to launch into the inclination of the moon, primarily because that's sort of like the plane of the planets. It's not perfect, but it's the way Kerbal does it. So we're just going to launch first of all. Let's get going straight away. Engines going. Fire the solids. Off we go. There we go, coming out of the shadow of the VAB. And off we go. So we can start tilting over reasonably quickly because of those solids, because the speed at which they're going to take us off the pad. and we get down to 85 reasonably quickly. So what are we actually thinking? Well, first of all, this is our standard launcher that we've sent things to the moon with, so it's pretty much a standard launch profile for it. We do have these SRBs that are going to come off any second now. We'll just get across there, and then they will no doubt die out about now, are they? Yes, they are. Decouple, and we've got one attached, which is annoying. I'm actually going to speed this up a bit. Oh, it's detached itself. That's nice. I am a little concerned about this craft. I'm actually, this is part of the reason why we have two of them, why we've got Discovery 1 and 2. If I was really happy with this launch vehicle, I would actually only probably launch one. I'd risk it for a biscuit sort of thing. But this first stage engine I'm pretty confident of. The solid boosters I'm pretty confident of. This second stage pair of engines I am not. They are the unknown for us. Primarily because, well, we got a funny visual glitch going on again there again. The sort of blurring almost. Because we've got two of them and they don't have the best reliability, shall we say, in the world. I think I worked out that they've basically got, in the burn time that we're asking them to do, they have a reliability close to sort of 90%, which is not great actually, if I'm entirely honest with you about this. Right, there we go, firing them. We've got the RCS on, so it'll straighten itself out. It does sometimes, this rocket looks a little bit fuzzy, and I'm not entirely sure why. It's almost like it's got a ghosting going on or something. Right, we've got a decent time to get up there. We're going to put this at about 5 degrees actually. We're now over the requirements to get rid of this, so we'll dump that. Now my concern is that I don't know if this will have enough fuel to put this whole thing into orbit. We may have to use some of this, so I'm going to rearrange my staging a little bit with that in mind. I'm going to put this down here, and I want to, and I'll just show you this now. This upper stage is pretty much the stage we sent to the moon, with the addition of a little bit of RCS there. So what I'm actually going to do is I'm going to take that RCS, I'm going to put it here. And I'm also going to take the RCS for our probe and put it down here as well. That gives us the ability to control the whole thing a little bit easier, because I'm aware that this RCS has limited fuel source, so I need to be careful with that. We could actually, and this is a possibility, we could actually enable crossfeed across this decoupler. If you really wanted to, you could do that. And it's not a negative, because you could have pipes in effect running down there to top this up, so this RCS would be topped up by that. The reason I tend not to is because I want to keep more of my RCS up here used up, so I will only activate that if these two little tanks run out, and they are likely to run out because we have very little RCS on this. This is pretty much just designed to allow us to settle the engine to start this up. It's not really designed for orientation so much, but we're probably going to use it like that, so that'll be interesting for us. Yeah, I do think we're going to need a bit more of upward. I don't mind losing a bit of the altitude, but we'll do that. Now we can actually have a look and see our vertical velocity is increasing downwards. Does that make sense? I don't know. So we want to fight that. There we go. We're going to slow that down. We're getting more towards. We're getting less negative velocity, shall we say? We're not going down as quickly. So we need to bring that up. We've got a little bit of time, and we don't mind losing it. I'd like an orbit of maybe between 160 and 180 ideally, so then we can get maximum use of the O-berth effect. We're not too close to, then to things like the atmosphere, which we could clip and things like that. So yeah, it's not a big issue. Right, there we go. So we're now going to have a little burnout. And I think we're going to be short a little bit, so what we need to do is actually, while I remember, I'm going to activate the avionics on this, because we shut it down, obviously, because when I'm designing them, that's what I do. So there we do that, fire that, there we go, get going. And we'll use a little bit of this engine, because we've got a lot on it, actually. It's not a bad little craft there for doing this. It's gonna use, what, 300-400 maybe. 500, maybe 500. We only need about 4,000 for the actual flyby that we want to do. We're actually wildly off there, which is not perfect. Oh, and I've stopped it early. It started again. We've got 5 burns on this engine, so I can be okay with that. Okay. I have not kept my mind on the relative inclination, so we're about a degree out. But this isn't like going to the moon. It's not as big an issue. So we'll see how we go. We may have issues with it. We may have to do a little plane change on the way there. So we no longer want to target the moon. We're going to come into the map view and we're going to target the Venus. I'm going to set a target. I always like to rotate round so that I have the sun and then the Earth like so, because then it's like a clock for me almost, and I can go, okay, yeah, we're definitely in the right place. Venus is behind us. It's going to catch up. It's a bit like when you're doing a docking. It's going to catch up. We're going to bring our craft down into a lower orbit, and we should, ideally, about here, we should meet. Now, hopefully by the time we get to there, Earth's about here, so the distance traveling of signal is not going to be far. If the Earth is further back, we may have a problem. We may have problems with the signal length, in which case we're going to need to upgrade our tracking station. So we need in our mind to be preparing to upgrade that tracking station. If we actually go and have a look, what we will do is we'll set this up and then I can talk to you about it. So how do we go about this? Well, we're going to go maneuver planet, and then we would go to advanced transfer to another planet. You can do this manually. You can use plugins that are like transfer window manager, all sorts of things like that. This is just the easy way of doing it. We've selected Venus, advanced transfer to another planet, pork chop selection, and there we go. And you can see the blues are the really low energy, and the further down on this board, this is quicker, and at the top here is slow. So if I wanted to take a year, and if I wanted to take departure 200 days, if I wanted to take a year and something to do this, I could do it. It would be 30,000 kilometers per second of delta V, which is pointless. But what we can actually look at realistically here is a nice one that is 3.8, for example, 3.8 or 3,800 kilometers per second. That's going to take 175 days. If I want to go quicker, I can actually come down here and go 5,000, gets me there in 90 days. So if I'm in a hurry, I can put a bit more energy in and do it quicker. But yeah, I'm going to go as soon as possible because I know that we're on a window here. If I actually, and you can zoom in, by the way, you can zoom in and see these things and stuff like that, and then you can reset. And what you can do is just draw a box like that, and you can see that the best point is there, 3.6. But I want to go as soon as possible because we've got a second probe to look at. So that's going to do that, reset that actually, and then go to that, and then we're going to create the node, and that says in 52 minutes we're going to do 3,671 meters per second. We've got more than enough delta V for that. What we can do is shut down that engine because I don't need to worry about it doing stuff, and we're sorted. So that is us just into the orbit there. I am going to, we can close this down. We can have a look at actually what we're going to look like. Now this is interesting, isn't it? Look, so we're going to come down. It's predicting we're going to depart Earth. We're going to come down, and you might not be able to see this on YouTube's compression. We're going to come down into Venus's orbit. We're going to pass Venus, and we're going to get a gravity push, and the gravity push is actually going to send us out towards Mars. So when we're down at Venus, we could actually have a look and see, are we ever going to get an encounter with Mars? That'd be quite cool. And what you can do is, let's see if we can do this, add a maneuver. Oh, we can't because we've not got a signal. But when we've got a signal, we could actually add a maneuver and just see that is there ever going to be a point where Mars is near to us? We'll set Mars as a target and things like that. But we'll have a look at that when we're around Venus, I think, just as we're approaching, because we might get something interesting out of it. I don't know. I've never done a Venus-Mars flyby before, so we'll see. Right. We have about 51 minutes until this departure, so I am going to get this thing set up, and then I will see you around departure time. Right, we are now within about 3 to 1 minutes of departure. We're actually going to turn the avionics on here as well because I can. We're going to do that. I've actually just realized I haven't deleted that, so we can do that now. Get rid of that. There we go. Right, we're going to put it on node. Our RCS is on, so we've now got RCS from this top section and the bottom section firing, which will be nice for us. We can get rid of the alarm clock, I think. Get rid of the alarm clock. There we go. Right. We've got about a minute to get into position. That's not a problem. This engine is currently deactivated. Okay. Now, one of the reasons I would actually make it deactivated if you've used it before is because you've got limited ignitions and you don't want to just firing randomly. But also, if we lose signal, you can actually have this craft orientate itself with MechJeb but you can't get it to do forward thrust with that unless you use the thrust control. But if you use the thrust control, this will fire, so you need to be a bit careful of that. So we're going to do this manually. We're not going to get the MechJeb to do the burn for us. We're going to do it reasonably manually, and then I will just have to refine it a little bit as I go. It'd be really nice if this thing actually hit Venus. I think that'd be quite cool, a little Venus impactor, but I'm not hurried to achieve that. So we have a short range antenna on this. We have our long range antenna on the probe. So once this decouples, our probe will not be able to do anything until its antenna is actually far enough away from Earth to actually do the interesting communication. So we're going to start some thrusting now with 7 seconds to go. We're going to use all of this that we can to give ourselves a little bit of a bump. And then we're going to activate the engine. There we go. And hopefully we're going to be all right. There we go. We are now underway. Right. We are off to the races, as it were. We've got a little bit of electricity charge being used because, of course, we've got both avionics right now running off all this. These little extra solar panels are giving us a little extra charge, but actually it's not much. This is where most of the electric charge is going to be coming from. And I'm hoping, because of the angle we're at, these are actually going to be retaining their sort of orientation to the sun reasonably well. Right. This is going to be a reasonable burn. So it says that we've got node in 43 seconds. We've got, it should be an interesting one. We should be okay for it. We're on the node. You could use either MechJeb's node thing, or you can use the stock SAS node, because of course RP-1 does come with that. It's got that option there to do that, so that's cool. We do not have a signal, however, which is annoying, so we're not going to be able to orientate anything other than node. I'd like to think that you'd actually, if you were using KOS or something, you'd probably actually have it programmed to do this for you. So, modern spacecraft would actually have it a pre-programmed thing. It goes, fire the engine at this point, at this angle, for this amount of time, achieve this burn. After this has been done, then you will go and do this, and then you'd refine it later. That's part of the reason why we've got some mass on this top stage. What I could have done is actually replace some of that mass with a heat shield and just gone for a direct dive into the atmosphere, but we don't need to do that yet, so I'm not going to. We'll do a Venus lander in the future. Venus landers are interesting though, because you get a lot of heat very quickly, so we'll see what happens with that. Right, so we are coming up to the point of where I have to start thinking about shutting the engines down. So we need to make sure that we're not actually hovering over anything, and we want to get this as close to bang on as possible, because we can then use this probe to do the refinements afterwards. So there we go. We're now leaving the sphere of influence of Earth. Just rotate around, and now we're at 100. So we need to be ready. Oh, there we go. Right, I shut that a little short, didn't I? There we go. Now, let's have a look. What are we looking at? Let's get rid of this. Oh, I can't do it. Right, shut that down. Right. This is the option. What we can actually do is, and this is a little cheaty, we're going to wait until we spin round, and then we're going to decouple and use the decoupler to give us a little bit of a bump, as it were. Oh, I never activated those. That's why they weren't doing anything. Okay. Right, so we're going to do that. I'm going to give that a little... When we come past this marker, we'll do a little bump, and it'll push our probe that way, roughly. At least it'll be helpful. So there we go, fire. There we go. It's given us a little push. Now, let's have a look. Can we... our avionics are not on yet. Now, this is the interesting bit. This is the interesting bit. So we can actually have a look and see where is our... Yeah, there you go. There's our range that we're going to get. We're not going to get a better signal until we're out here somewhere. So let's just go a bit faster. A little bit faster. Got some minutes going on there. We're getting power. The power's coming in. That's good. So we're actually rotating in such a way that we get power. And our signal's going to come in at some point. Oh, we're coming to a warp. What's the warp for? Oh, I know what it'll be. It's the departure window. Transfer point. Okay. Close that, because we've launched this one. We're gonna launch the next one soon. All right, this is going to be our receiver here. So we're going to hit that soon, I think. So you're going to see our signal kick in there. Right, here we go. Come on. Oh, it's migrating. It's just on the edge. There we go. Right, there we are. Yeah, we've just hit it. Right. So we can get rid of that. And we can go and have a look at this. Now, how far away are we? That is the question. We are not great. Okay. So I want to go and I want to put this craft. I want to turn off the node. I'm gonna focus view on that. I'm gonna put us. Hello. Why do I not have any control? I have avionics, don't I? Avionics is on. Avionics is on. Hello? I'm sure I have avionics for this. Unless it's over mass. That's a problem. Right, let's have a look. Let's do if we can do this cheekily. Other way. Right. We're going to just do a little bit of RCS maneuvering now. Right. There we go. And what we're going to do is just fire our RCS to do this, which is so cheeky. It's actually unbelievable. Right. And as we come past, and this is basically just, we're going to use the rotation of the craft to do stuff for us, which is not what you should really be doing. So when we're near this one, we're going to fire them in one direction. And then when we go past it, there you go. When we come past it, we're going to fire them the other direction. And I'm not sure why we can't orientate. Turn that off. Orbital prograde. Is it doing that? It's not. Right, so this process can take time. And I'm still not sure why we do not have orientational control, because we've got signal. I'm pretty sure we have enough avionics. Let's have a look. Controllable 0.5. Actually, we can check this out, can't we? So we've got 0.5 tons. What is the vessel info telling us? How much do I have? Ah, now this is interesting. We put equipment onto this vessel, which has taken it over 0.5 tons. Right. Okay. So that's a problem. Note to self: get rid of some fuel. I wish you could actually select which fuel to get rid of, but obviously we cannot. So we're going to just do this the old-fashioned manual way of burning a bit of fuel off somewhere. There we are. That's the way I want to go. We're going to do this until we get the fuel down a bit, and you can see our separation is going down there. It's not the most efficient way of doing this. There we go, going down a bit more, and then we're going to stop. Right, let's have a look. What's our vessel info saying now? We are at 0.5 tons. Okay, so we should be getting control back at any moment, which would be really nice. There we go. We have control, so we can now put ourselves on prograde. Hello. Onto prograde. Hello. Come on, get yourself round. Why is it taking so long? Let's turn that off. Get this on. Let's put us on prograde like this. That's easier. No, they're all terrible. Okay, so we have we've got our RCS right in the middle of the craft, and it's not the most efficient way of doing it, but it is the way to have the lightest RCS, because I don't want to put multiple pairs on. So there we go. Right, we are now sort of that. Right, now we can actually do this again with a little bit more intricacy. There we go. So we're going backwards a little bit, and at some point we're going to get to the point where we're actually going to have an encounter. We're just doing a little bit of retrograde burning now. We're just RCSing and backwards. Now, because our little 1 kilonewton thruster is actually using the same system as the RCS, it doesn't matter if we use the little RCS or we use the 1 kilonewton thruster. We could actually have got away without the 1 kilonewton thruster and just gone with RCS, because the burns at this point are pretty minor. But we will see. So we're going to... Oh, got a bit of a freeze there. It's auto-saving. I must learn how to change the auto-save time. I must have a look at that, because it seems to do an awful lot. So yeah, let's have a look. We're going to come down. We're within quite a distance now, actually. We're getting quite close. So we should be getting an encounter at some point, like within the sphere of influence. I don't know what the range is on it. It's quite interesting actually. I didn't think it would go this far. There we go. Right, now we can zoom in and have a look. Right, yeah, there we go. Now we're going to find out what sort of encounter is it going to be. Is it going to be equatorial? Is it going to be a polar encounter? I don't know. What we could do is we can just turn the craft around and use the main engine. We could actually use the engines on the craft to do this. One of the other reasons for actually putting your RCS in the middle instead of at say one end or the other is because the way that KSP models sort of force about a body, because of the moment of inertia and things like that, I'm not going to get into it, it sometimes throws off these values significantly just by rotating the craft like this. So you can end up with an odd situation. There we go. We're going to fire a little thruster there, and that's a much quicker way of doing it. Right. And we can just now go in and open. And then we could do maybe a bit of like so. Okay. So we're going to come in over the pole. Now, we could, I think, have a look at what can I do maneuver-wise to get closer when we arrive. Because we would like a nice close approach, wouldn't we? We'd like to maybe come in close. How much is that going to cost me to get in? Yeah, we've got more than enough to do a nice close approach. And what does that do to me on the other side, as it were? What does it do to my orbit? It's okay, so we're no longer going to have that interesting Mars orbit, which is not a big issue for me. I don't mind. It would have been nice to have it, but I think partly by the way that we burn, partly by the changes we've had to make, that's actually what we're doing. So, okay, we're going to do that, and then we'll refine it when we get there. And if we can't, well, that's our problem, isn't it? But we're going to have a reasonably close approach, I think. What is that going to be? 19. I don't know what the mission requires actually. So let's see. Can we just? In fact, I'm going to put a little bit of time warpy on, and we're going to pull this like so. We're just going to do a little bit of translation, like so. Okay. So what I'm actually doing now is I'm doing a little bit of translation where we are. And we're just working it down. We're just going to work it down. And this is actually instead of me doing this once we get to a nearest approach. And what I could do is, if I really wanted to, we could. Oh, a little bit of glitch. We could. I could, if I really wanted to, I could go properly polar. What we could do is actually go equatorially, or more equatorially, if we so wished, like so. Okay, more like that. That's very nice, isn't it? That's very close. So that's a very close pass, and that's going to put us. I think the Earth will be trailing at that point, so that would actually be on the right side of the Earth. I think let's just zoom out a bit. Yeah, I think the Earth would be behind. So the Earth should be pretty much behind at that point. So we should be facing the Earth. So we get a signal. We should get a signal at that point. Wonderful. So, is it getting electricity? I'm not entirely sure. Let's have a look. We can get rid of that thing that's sticking down. We now notice that our mass is below 0.4. Right. Where are we? Let's have a look. We need to check our. What am I checking? Oh, I'm checking power. So that would be here. Where we're going? Right, we're on 0 at the moment because it's getting it. We could actually shut down avionics, which will save us even more power, and we could actually activate all of these things as well while we're doing. Close that while we're doing things. So we'll turn that on. We'll turn the pressure on. They're not going to do anything yet, but when they get into interplanetary space, they're going to give us some science, which I had forgotten about because we have something else lined up. So I'm going to leave that there.